Okay, hello everyone. So, welcome to Lecture 8. So, in the lecture 7, we discussed about the informed search algorithms. What are informed search algorithms, how they are different from uninformed search algorithms. So, what are the main difference? Ki informed search algorithms uses the one extra information about the problem statement called heuristic information or heuristic function, and this heuristic function was computed by relaxing some of the constraint of the problem. So तो हम किससे रिप्रेजेंट कर रहे थे heuristic function को h of n से. So we talked about this heuristic information, then we talked about a informed search algorithm called greedy BFS, which was using the f of n equal to h of n to remove the nodes from the frontier. So this is what we have discussed in the lecture 7, and we also talked about key that greedy BFS is not optimal. Okay. So now in this lecture 8, so this will be the last lecture on these informed search algorithms. So in this lecture 8, we'll talk about the A star search algorithm. So this A star search algorithm, as we briefly discussed in the last lecture, uses the Fn equal to Gn plus Hn. So the actual cost from start to node n, and the estimated cost into goal. So we'll talk about the A star search algorithm, which uses the both Gn and Hn. We'll also talk about the properties of the A star, like whether it's a complete, it's optimal or not, what's the time complexity, what's the space complexity for it, and we also talk about the admissible and consistent heuristics. So in the last lecture, I briefly discussed about the admissible heuristics, but we'll dive into the more details. Why do we need the heuristics to be consistent and admissible, and how does the heuristic being admissible and consistent benefits the our search algorithms? Okay, so let's first start with the A star search strategy. So A star, or you can also say A. Okay, so as we have discussed in the last lecture itself, it uses the frontier priority queue. So this is the third algorithm that we have discussed so far, which uses the frontier priority queue again. So since the frontier is priority queue, we need some kind of criteria or a priority to remove the nodes from the frontier. So what criteria does it follow? It uses the Fn equal to Gn plus Hn as priority value for nodes or states. So how does it remove? So A star removes node having lowest value of Fn from the frontier. So value f1 from frontier. So A star क्या करता है? A star will remove the node which has the lowest value of f1 at any moment of any time and explore that node. ठीक है? So जैसे हम नोड कोई नोड निकालने वाले होंगे फ्रंटियर से, we'll check कि among all the nodes which are in the frontier कौन सा नोड है जिसके लिए f1 की वैल्यू सबसे कम है, and will remove that node from the frontier and explore that node whether it's a goal node or not and add the successors. Okay, so we already talked about this. So if we so what is this f1? Another name for this f1 is evaluation function, which is consists of two terms, gn. This is the actual path cost from starting state or initial state to current node. So you need to be careful about while calculating the gn for any node f1, since that it's a actual path cost. That means कि it is a sum of all the actions की जो कॉस्ट है फ्रॉम द स्टार्टिंग स्टेट से करंट नोड तक पहुंचने में, जो एक्शंस हमने लिए हैं और आपके एआई एजेंट ने लिए हैं, उन सब में जितनी कॉस्ट पे की है, तो उन सब का कॉस्ट का सम होता है जीएन. राइट, दिस वी डिस्कस्ड in very detailed manner while we are discussing about the UCS. True. State. ठीक है, and this another value is HM, which is estimated cost from node N to goal node. तो यहाँ पे I'm using go node and state exchange interchangeably, but you know what it means. So this is what we are using as a our removable criteria or the priority in priority queue for removing nodes. Okay, so we'll remove the node which is having the lowest value of fn at any moment of time on frontier. Okay, let's see this in let's see the a star in action on example, and we'll discuss all the details there. So let's continue with our example of the Romania. And so what's the starting state? This is the initial state or start state, and this is the goal state. Okay, so these values जो edges के ऊपर लिखी हुई है, these values are the gn values, or technically these values are the cost of an action. So this is the cost of an action. So gn values will be sum of all these action costs, and these values जो this table में गिवे हुए, these are called hn or heuristic values. ठीक है, so let's work with our example. So let me draw our frontier. So okay, let's draw our frontier here itself. Okay, so this is my frontier. Um, okay, so this is the priority queue. I know this is simply a container, not a exact implementation of the priority queue. But we have discussed that this implementation can be varied depending upon how you want to implement priority queue. Like whether if you want to implement the priority queue using min heap, max heap, then you can have the different implementation, or if you want to implement priority queue as a linked list or something, then you can have the different implementation. So instead of so not going into the exact details of the implementation, we are taking an abstract view of our container or the frontier as a simple container. So here we are writing priority and remember. And this is explode set. Okay. So this is my explode set. Okay. So and another thing that we need to maintain is called search tree that we can maintain accordingly. Okay, so what's the initial state or initial step of our algorithm? We'll add, we'll start with the initial state being in the frontier. So our A being in the frontier. Now our Fn is okay. So Fn is so this is the initial state. Okay, so our Fn is Gn plus Hn. Right, so for any node, I'll keep maintaining these values of Gn plus Hn ताकि we can keep track of this. So f of a क्या होगा? F of a will be g of a. G of a कितना होगा? 0, because gn क्या होता है कि स्टार्टिंग स्टेट से कॉस्ट, तो स्टार्टिंग स्टेट तो सिंस a ही है तो will have that as a 0, and the h of a क्या होगा? H of a यहाँ पे given जो है 366. Okay, so what will be the value for f of a? 366. Okay, good. So now what? Remove a node from the frontier, right? Okay, so let's remove the node from the frontier and then we can continue with. So which nodes should we remove? Since there is only one node at a time, so we'll remove the node A from the frontier, add it to the explode set, and add it to the our search tree itself. Now what? So since A being explode, A के जो भी neighbors है वो add होंगे. A के neighbors क्या क्या है? S, T, and Z. So these are the three neighbors of A. So let's add these. So let's add f of s. F of s क्या होगा? G of s. So G of s will be cost from starting state, which is 140, plus h of s. तो h of s क्या है? H of s is 253. So what's this value? 140 plus 253, which is 393. So our s will be added with the cost 393. Similarly, let's talk about t. तो f of t क्या होगा? तो t के लिए g of t वैल्यू क्या है? 118 प्लस h of t की वैल्यू क्या है? 329. तो it will be 118 plus 329, which will be 447. And z क्या होगा? Let's calculate it for the z also. So f of z. So in the exams also you can maintain this kind of data because we are gonna need this gn value later on also. क्योंकि we know that कि gn की वैल्यू क्या है? एडिटिव है. तो s के सक्सेसर्स होंगे वो gn की वैल्यू क्या होगी उनके लिए? Which will be value of gs plus the cost of s to सक्सेसर तक जाने की cost, right? So f of z क्या है? 75 plus z cube h of z, which is 374. So what will be this? So we can use the calculator for 374, which will be 449. So please keep verifying these. When you watch this video, do verify these values in case I made some mistakes in it. 449. So now that we have added all the successors, we'll check कि कौन सा successor है जिसकी cost value सबसे कम है f of n. So we'll see that कि s is the successor with the lowest value. So we'll remove s, add it to the explore set, and add it to the search tree. So we have explored s. तो s के कौन कौन से successors है? S के successors है f, which will be added into the frontier, r and o. Right? These are the successors of s. So let's add these. तो f of f क्या आएगा? g of f. तो g of f की वैल्यू क्या होगी? 140 प्लस 99, राइट? तो 140 प्लस 99 ये कितना होगा? 140 प्लस 99, which will be 239. प्लस h of f क्या है? h of f is 176. ओके, तो 239 plus 176 is equal to 415. So f will be added with cost 415. Right? Similarly, what about o? तो f of o, तो o की cost क्या होगी? Cost till s, तो g of s प्लस इस एक्शन की कॉस्ट जितनी है. तो g of s कितनी है? 140 प्लस इस एक्शन की कॉस्ट कितनी है? 151. So this will be 140 plus 151, which is 291. So that will be the g of o plus what is the h of o? So if I talk about h of o, that is 380. So this will be o will be added with the cost 671. And now let's talk about r. f of r, तो f of r के लिए g of r क्या होगा? g of s प्लस इस एक्शन की वैल्यू जो s से r तक जाने के लिए राइट, बिकॉज आर तक के लिए जी ऑफ, जैसे जी ऑफ आर क्या होगा, आर एस का सक्सेसर है तो जी ऑफ एस प्लस कॉस्ट जो है उस एज की कॉस्ट, तो एक तरह से एस और आर के बीच का जो एज है उसकी कॉस्ट, राइट। तो इसको मैं ऐसे भी कर सकता हूँ कि कॉस्ट ऑफ एस टू आर का जो एज है, राइट। तो दिस इज कॉस्ट ऑफ 140 प्लस दिस इज 80। तो एफ ऑफ आर के लिए जी ऑफ आर विच विल बी 220 प्लस एच ऑफ आर, तो एच ऑफ आर क्या है 193, तो आर विल बी एडेड विद द कॉस्ट 413। Okay, now that you got this कि how r की कॉस्ट कैसे आई है, क्योंकि r के थ्रू कैसे गए हम, पहले a से स्टार्ट किया हमने, a पे s से गए और s से r पे गए, तो a से s तक की कॉस्ट प्लस इसकी कॉस्ट, ये हो गई इसकी gn वैल्यू, g ऑफ r, बिकॉज वी आर टॉकिंग अबाउट एक्चुअल कॉस्ट है, और एस्टिमेटेड कॉस्ट क्या है, इससे यहाँ तक की कॉस्ट जो एस्टिमेटेड कॉस्ट है h ऑफ r which is given into the table here, so that's why we are okay. So what now, we'll again check कि कौन सा नोड है जिसकी वैल्यू सबसे कम है and we remove that, तो कौन सा नोड है जिसकी सबसे वैल्यू कम है, r with 413, तो let's remove r, r किससे के थ्रू ऐड हुआ था, s के थ्रू, तो we have removed r, तो we have traveled over this path and reached the r, तो r के अब क्या क्या सक्सेसर्स है, r has two successors p and c, तो we need to add those, तो let's calculate f of p, f of p क्या होगा now, f of p क्या होगा, g of p plus h of p, तो g of p will be g of r प्लस इसका जो कॉस्ट था that is 97, तो g of r क्या था, तो that's why I was keep maintaining this values, right, कि g of r था 220, तो 220 plus 97 कितना हो गया, that will be 220 plus 97, that is 317, तो 317 plus this was only g of p, तो h of p क्या हुआ, h of p निकाल सकते हैं, h of p यहाँ से आ जाएगा which is 100, तो p किस कॉस्ट के साथ ऐड होगा 417, ठीक है। एंड लेट्स टॉक अबाउट c, सिमिलरली f of c क्या होगा, g of c, तो g of c क्या होगा, g of r प्लस 146, तो g of r क्या था 220 प्लस 146, this will be 366 प्लस h of c, तो h of c क्या है 160, तो what will be this will be 526, so our c will be added with 526, okay। Now back to our algorithm, remove one node, तो कौन सा नोड रिमूव होगा, कौन सा नोड रिमूव होगा, जो जिसका कॉस्ट सबसे कम है, तो किसका कॉस्ट सबसे कम है, f का with 415, तो रिमूव f, एंड f किससे ऐड हुआ था, it was added from s, तो we'll add f into the frontier, sorry f into the search tree, and we'll explore f. So we'll explore f. f का क्या सक्सेसर है? There is one successor of f which is b. So f of b, let's calculate f of b. f of b क्या होगा? g of b. So g of b will be g of f plus 211. तो g of f क्या था? g of f was 239 and 239 plus 211, right? So 239 plus 211 which will be 450 plus h of b. h of b क्या है? 0, क्योंकि since it's a goal node, तो h of b will be 0. तो और b will be added with cost 450. तो अभी ये b जो एड हुआ है that is being added through f, इस एज के थ्रू, राइट? गुड. now what? again repeat our algorithm. remove a node. तो कौन सा नोड रिमूव होगा? p, because now its cost is 417. तो remove p किसके थ्रू ऐड हुआ था? r के थ्रू. एंड तो we have removed p and we'll explore p now. तो p के कौन कौन से सक्सेसर्स है? p has two successors, b and c. Since both c and b are already in the frontier, but there is still chance of updating their cost, right? So let's calculate कि उनके लिए f of c की वैल्यू क्या आ रही है, दोनों केस में, एंड देन विल अपडेट कि अगर है या नहीं. तो f of c की वैल्यू इस केस में क्या आ रही है? f of c अगर मुझे कैलकुलेट करना तो दैट विल बी g of c प्लस h of c. तो g of c क्या होगा यहाँ पे? तो g of c विल बी g of p प्लस इस एज की कॉस्ट कितनी है? 138 प्लस h of c कितना था? 160. तो g of p हमारे पास ऑलरेडी गिवन है. g of p is 317. तो दिस विल बी 317 प्लस 138 plus 160, and if I calculate this, so 317 plus 138 plus 160, so that will be 615, which is greater than f of c, जो कि यहाँ पे ऑलरेडी है. This was 526. Sorry about that. 526, right? So 3615 is greater than 526. That means कि will not update the cost. So will not update the cost for C. So we can simply say कि this action won't be taken or this edge won't be followed. Now let's talk about this one कि यहाँ से B के लिए क्या वैल्यू आ रही. तो f of B क्या होगा? g of B plus h of B, which will be यहाँ पे g of P क्या होगा? Since it is explored through P, it will be g of P plus जो cost है 101 plus h of B which is 0. तो g of P क्या है यहाँ पे? g of P is already given 317 plus 0 which is 418. And we realize this कि this is better cost, right? That means कि we have found a better path from path to B through P. So now what we can do? We can update the cost and we'll say that कि F के through हम B पे नहीं जा रहे अब, तो we can remove that and we are going through P itself. तो we can update the B's cost. इसको हम अपडेट करके क्या कर सकते हैं? F of B will be 418 plus 0 So this will be updated cost for B. So you can update the B's cost with 418. And okay, so now again what? You'll remove the node. कौन सा node remove होगा? B itself. To remove B. Now since ये P के through explore हुआ, and since we have found the goal node, since this is a goal node, we can simply terminate the algorithm. So goal node, and so that means terminate search. So that's where our search algorithm will be terminated, even though there are other nodes in the frontier. And the what will be the path written by this algorithm? Path will be path you can follow in the search tree. That's why we keep maintaining the search tree here. Path will be path slash solution. So that will be A to S, S to R, R to P, P to P. And since we know that this is the optimal path, in this search. So this is true that A star does use the optimal path. So if you talk about the properties of A star, so completeness, yes, it is complete. So the A star is complete, so that's not an issue. Okay. Optimality, yes, but only if F or Hn is admissible and consistent heuristic. What do you mean by admissible? What do you mean by consistent heuristics? We'll talk about that. So okay, and time complexity. So A star has the time complexity of so A star has the time complexity of B to the power epsilon D, where epsilon we already know is the minimum cost assigned to each action. Right? Remember we talked about this epsilon cost in great details, why it is necessary and all when we were discussing about the uniform cost search. Space complexity is this is also same, since all the nodes need to be stored into the priority queue. So this will all into this. Okay, now let's talk about these two. What are these two things? Admissible and consistent heuristics, and why. So what we talked about heuristic function in great detail, right? What was this? This was the estimated cost from any state slash node m to goal state. So this was the estimated cost, and we talked about that key this estimated cost should be like always less than equal to actual cost, because since we talk an example of straight line at key, if we want to go from city A to city B, the so what will be the shortest distance between these two? It will be a straight line distance, right? कि अगर मुझे ए और बी के बीच में ऐसे ट्रेवल करना है कि मैं शॉर्टेस्ट डिस्टेंस ट्रेवल शॉर्टेस्ट मतलब मुझे अगर ए से बी जाना है, बट मुझे जो डिस्टेंस ट्रेवल करनी है वो सबसे कम होनी चाहिए, तो व्हाट्स द बेस्ट वे? जस्ट गो स्ट्रेट, राइट, follow a straight line path and you will reach the A to B in a shortest while traveling shortest distance. And this, so अगर आप बट ये कैलकुलेट कैसे कर सकते हो shortest distance? You can calculate, this can be calculated. So आप डिस्टेंस के बारे में हमने पढ़ाई है, तो that is Euclid distance function you already know, you must have studied in the other courses. तो यूक्लिड और इन हाई स्कूल मैथ्स ऑल्सो की दो पॉइंट्स x और x1 y1 एंड x2 y2, इन दोनों के बीच की जो शॉर्टेस्ट डिस्टेंस होती है, लेट्स सपोज इस पॉइंट को मैं a बोल रहा हूँ, इसको पॉइंट को b बोल रहा हूँ, तो d ऑफ a b विल बी x2 minus x1 का होल स्क्वायर प्लस y2 minus y1 का होल स्क्वायर. So this is the shortest distance we, or also known as the Euclid distance between 2 points. Now you must be thinking कि ये तो दो पॉइंट्स के बीच की दूरी है. How can we calculate this in this same for two cities? Because cities में सिर्फ एक पॉइंट पे थोड़े ना होती है. तो what we can do, since that's where this estimation come, we are not worried about the actual cost, क्योंकि actual cost हो सकता है आप जो path follow कर रहे हो, this path might go from somewhere else, from different cities along the path, and you are following that. The actual cost might be very large, but we are only talking about an estimation, ताकि हमें आइडिया लग जाए कि जो एक्शन हम लेने वाले हैं, that action can leads us to the closer to the our goal or farther away from the goal, right? So to calculate this, or how can we calculate the shortest distance between 2 points is, if you're talking about two cities, we can say that कि जैसे आपने कोऑर्डिनेट सिस्टम्स के बारे में पढ़ा होगा, राइट? Each city has a longitude and latitude, right? So each city has this longitude and latitude, right? Latitude. So each each city can be defined in the coordinates. तो इसके कुछ कोऑर्डिनेट्स होंगे, तो इसके latitude को I can say x, और right, और x1, and longitude को y1, and इसके लिए क्या बोल सकता हूँ मैं, similarly x2 y2, and I can use this distance formula to calculate the distance between these two points. So this is one concept of the heuristic function, and so अब एक यही तो heuristic function नहीं हो सकता, और भी heuristic functions हो सकते हैं. We can define any other estimation for the cost, but we'll in this course we'll only talk about the heuristic functions which are which estimate where estimation cost is always less than. So estimation cost or estimated cost should be less than equal to actual cost. So these kind of heuristic functions are known as admissible heuristic functions. ठीक है? So What are the admissible heuristic functions? Admissible heuristic functions are functions which which gives the estimated cost which is less than or equal to the actual cost. So actual cost model हमने define किया, that should be greater than or equal to estimated cost. Okay. And what about the consistent heuristic? So let me take an example. So let's suppose we have this node n and this is my goal g. ठीक है, तो h of n क्या होगा? H of n will be this, right? So h of n will be this straight line distance, and let's suppose is n का एक ही successor है, there is one successor n prime, so there is a successor n prime of this, तो और ये n prime से यहाँ तक जाने का जो cost है, that cost I am defining it as a c. तो let's suppose कि this was action a जिसके थ्रू ये n से n प्राइम गए हैं, तो इसकी कॉस्ट को मैं डिफाइन कर रहा हूँ n a n प्राइम की n से x a के थ्रू n प्राइम तक जाने की कॉस्ट, right? Or you can, in short, you can simply say c, but just to consistent with the notation given in the book, I'm thinking this is the c is the cost from n to n prime through action a. Now what? So h of n prime क्या होगा? H of n prime will be this straight line distance. This way, right? तो मान लेते हैं कि okay, तो n से गोल तक जाने की एक्चुअल कॉस्ट क्या होगी? एक्चुअल कॉस्ट आई एम टॉकिंग अबाउट n टू गोल, तो इट विल बी, तो g ऑफ n क्या होगा? c n a n प्राइम प्लस यहाँ से यहाँ तक जाने की कॉस्ट, राइट? कॉस्ट फ्रॉम n prime to g, and since it will, right? Okay, so if we realize this, can, this diagram can be visualized in terms just like a triangle. So from this, what I can say, this h of n should always be less than equal to c n a n prime plus h of n prime. Okay, why? Because if you talk about the triangles, triangle inequality you must have heard, right? Triangle inequality. What is triangle inequality? Sum of two sides of a triangle is always greater than third side, right? So, from this we can derive this h of n should always be less than equal to h of n prime plus cn nhl. Why not only less than, why not less than equal to instead of less than only? Because there might be some cases like n say n prime and this is g. We all three lie on the same line, same state line, जहाँ पे फिर एच एन और जी एन की values will become kind of same. That's why this will become equality. Okay, so all the heuristic functions which follows this property are known as a consistent heuristics. Consistent heuristic functions. And we realize that कि अगर कोई heuristic function is consistent, so this is what if a heuristic function is consistent, then it is also admissible. So that means कि this consistent heuristic or consistency is stronger property. Okay. So for A star to be optimal, for A star to be optimal, a heuristic function should be Hn should be consistent, Hn should be admissible, and consistent. So if someone asks you कि given this example कि इस example पे A star optimal solution देगा या नहीं देगा, तो what you can do, you can simply check whether कि आपका जो heuristic function given है that is consistent and optimal. So consistent and admissible, then only A star will be able to give the optimal solution. So since this consistency means कि admissible automatically हो जाएगा, तो you need to only check consistency of the heuristic, and that will give you the whether A star will give this optimal path or not. Now we can talk about the proof of the optimality, proof of optimality for A star. कि how, why do we need these two properties to be true for the A star to be optimal? So, but that proof is given in the slides. You can check those slides. But the ideas will not dive into that. The idea is simple. Remember, how can we sure कि जब भी हम फ्रंटियर से कोई नोड निकाल रहे हैं, जब भी फ्रंटियर से नोड निकाल रहे हैं, we are sure that कि whenever when we remove a node the state from frontier to explore, shortest path till that node has been found. So this is the idea behind the proof of the A star for optimality, and similarly for UCS also. कि UCS and A star are optimal, and why this? Because जब भी हम कोई नोड फ्रंटियर से निकाल रहे हैं, we are sure that कि जैसे ही नोड को हमने निकाला उस तक का शॉर्टेस्ट पाथ हमें मिल चुका है. बिकॉज एक बार जैसे नोड फ्रंटियर से निकला, वो नोड वापस फ्रंटियर में कभी नहीं जाएगी. तो जैसे ही अब तो हम जैसे निकाल रहे हैं, तो अगर वो वापस ऐड नहीं होने वाला, दैट मीन्स कि उस तक का शॉर्टेस्ट पाथ हमें मिलना चाहिए, राइट? So this property is always satisfied. You can say this property, and this is satisfied because of our heuristic function being consistent. And अगर ये property true है, तो for example, if I go into this, let's suppose कि जैसे ये सर्च स्पेस है, यहाँ पे दो गोल नोड है, ये वाला और ये वाला। तो होगा क्या, जैसे सबसे पहले जो भी रिमूव होगा, अगर ये रिमूव होता है, दैट मीन्स कि इस तक का पाथ हमें शॉर्टेस्ट पाथ मिल चुका है, राइट। दैट मीन्स कि इसके बाद के जो भी एजेस आने वाले हैं, जो भी नोड्स आएंगे इसके, उनकी कॉस्ट हमेशा इससे बड़ी ही होगी। तो जब भी कोई नोड निकलता है और उसके सक्सेसर जब भी ऐड होते हैं, उनके सक्सेसर्स की जो वैल्यूज है, और जो that will should be always be greater than this one। तो जब भी कोई नोड निकलता है, तो देयर आर टू थिंग्स। वन, जब भी कोई नोड निकलता है तो उस तक का हमें शॉर्टेस्ट पाथ मिल चुका है। सेकंड, so this is the property 1, and property 2, property 2 property 2 is कि when, और सिंपल में, all the f1 value are non decreasing। so that means कि किसी भी नोड n के लिए उनके उसके जो भी सक्सेसर्स है n1, n2 और n3, तो f of n will always be less than equal to f of n1, f of less than equal to f of n2 and less than equal to f of n3। इन तीनों के बीच में क्या होगा, वी डोंट केयर, ये कोई एक बड़ा हो सकता है, कोई एक, बट ये सारे मिलके f of n से बड़े ही होंगे हमेशा। दैट मीन्स कि हमेशा f of n की वैल्यू ऑलवेज इंक्रीज। तो जो भी सबसे पहले हमें नोड मिला, which will have the lowest value of f of n, उसके बाद जो भी नोड्स हैं वो, और उनके लिए f of n की वैल्यू हमेशा ज्यादा ही होगी। तो अगर ये गोल नोड पहले निकल रहा है, दैट मीन्स कि इस नोड के लिए f of n की वैल्यू है which will be less than compared to this value, right? Since f of n की वैल्यू कम है और गोल नोड के लिए gn, तो गोल नोड के लिए f of n is equal to gn itself, right? gn itself, that means कि gn की वैल्यू भी इसके लिए कम होगी compared to this one। तो that means कि this will be optimal solution, right? So this is the rough idea how we can prove the optimality of the A star। The much more detail, or these properties and more detailed, can be found in the slides। We'll not talk about here as, ठीक है। तो in on course page you can find the slides and you can see the proof in there। Okay, so with that we have complete, so what we have completed so far in the course, we have completed uninformed search algorithms, uninformed search, right? तो इन uninformed search में हमने BFS पढ़ा है, DFS पढ़ा है। तो BFS क्या करता है, it uses the Q as a frontier, right? DFS uses the stack as a frontier, DLS runs DFS in the background with limit L, IDS runs DLS with L बराबर 0, 1, infinity। So technically these three are DFS variations। You talk about UCS, which uses the priority queue. Since this is the first algorithm that introduces the concept of path cost, ये सारे तो path cost को consider भी नहीं करते. Then we talk about informed search algorithms. उसमें हमने क्या पढ़ा था? Greedy BFS, which uses the h of n, and a star, which uses the g of n plus h of n, and both uses the priority q as a frontier. So this is the g of n. Okay, so this was this overall summary of our lecture so far. Okay, so in the next lecture we'll do some more problems on these algorithms, and then we'll move on to the more advanced topics like local search algorithms and so on. Okay, with this, let's stop here and let's meet in the next lecture.